All right, and welcome to another episode of the Physical AI powered by Phygital, where AI meets the real world. And today we have a special guest, Kaylin Song. Together in this podcast, we actually have the pleasure to interview talents like Caitlyn Song, together with scientists, founders, where we explore how machines actually are interacting with AI, intersection of AI and human behavior convergence. How are you today, Kaylin?
I'm doing good. How are you today, Tommaso?
I'm doing awesome. Very excited to do this. Allow me here to introduce real quick Kaylin. Kaylin is PhD researcher at the Carnegie Mellon University Language Technology Institute, exploring generalist agents that bridge language, reasoning, and action. Her work focuses on web and API based agents. And we're talking about that today. These are systems that perceive, plan, and act through structured digital environments, advancing how AI learns to do things, not just to say things. She develops hybrid symbolic neural architectures that enable agents to reason compositionally, interact autonomously, and generalize across diverse tasks. Kaylin is at the frontier of agentic cognition. So Kaylin researches the primary purpose lies in the groundwork of the next evolution of embodied intelligence, where language becomes action and reasoning becomes behavior. This forms a conceptual bridge between cognitive AI and physical AI. Very, very excited. Are you ready to jump into a couple of questions here, Kaylin?
Yes, I'm all ready.
All right, all right. Let's talk a bit about standardized in intelligence. I wanna deep dive on the work that you proposes of the Universal Interlingua, the ADP, which is the Agent Data Protocol, right? Which is the interlingua for agent data set. That's a schema unifying API calls, code actions, and web interaction across 13 sources, right? So what becomes possible when we treat data format as infrastructure and not just afterthought? What can you share with us? What learnings do you have most recently learned here, Kaylin?
Yes, so treating data format as infrastructure but not afterthought is actually the hard design of agent data protocol. If you want to unify data under a single schema, you need to stop treating format as a like housekeeping and start treating it as an infrastructure. It's a shared operating layer for intelligence. Before we introduce agent data protocol, each dataset has its own, let's say, its own island. For example, one log browser clicks, another log code edits. But with ADP, before ADP, we couldn't combine them without months of custom engineering for each dataset. But with agent data protocol, all those actions and observations become comparable, replayable, and composable. So suddenly we can train across datasets, like across datasets, not just one dataset or like a limited number of datasets. We can compare reasoning behavior across different domains. Like we can compare across browsing, across coding, across researching, and even reuse individual trajectories as reusable units of learning. So instead of training one model per dataset, we start building generalist agents that can learn how to act and reason, not just how to mimic a single benchmark or a single action or single domain. So this is like that's how we develop ADP.
That is very interesting. So to follow up on this, the ADP, right? How would it change actually, or even measure uh, uh, the fact on reasoning or reuse trajectories or even a debug, right? Agent failures, right? Doesn't make sense.
Yeah, that makes sense. Like I think the biggest thing here is measurability. Um, if we like when we came up with a shared action schema, we are not limited to tasks succeed or failed. we can evaluate each decision that agent made. Like, for example, in a trajectory, does it pick the right tool to use? Does it like bind the arguments of the tool correctly? Does it recover gracefully from an error, etc.? Like you can imagine this like having a structured metric like to ground the accuracy or repair recovery rate or planning efficiency. So this turns, for example, reasoning into a quantifiable process, not a black box as before. And also debugging becomes more engineering again. For example, field trajectory isn't just a vague log, it's a sort of unit test like in software engineering that you can replay, modify, and inspect deterministically across environments. It's the difference between like whether you could reuse stuff and measure stuff before compared to not and before.
Yeah, thanks for sharing this. This is very very compelling and definitely an advancement. Now, in the age of robotics, right, and taking an assumption that the ADP would become, let's say, a default a log language, right? And real robots would adopt it, right? So we have obviously this big issue of safety, right? Safeguards, provenance, schema validation, right? Or even data hygiene, which are always related to enforceability, tied to imagination versus hallucination. So what would we need to truly do and mature into to avoid imaginations versus hallucination?
This is a very good question. I think the key thing to keep imagination from turning into hallucination is that um, we need trust through structure. Like we need every trajectory. Every trajectory needs, let's say, provenance metadata, like what the data set it's come from. What's the environment version, for example? Let's say pip package version or which tool or APIs it's using. So with this information, when a model makes a decision, like we can trace the lineage of that behavior instead of like knowing nothing of what does the decision come from. We also need, like in agent data protocol, we also need schema validation, where we strictly um, we strictly manage a type for each action parameter and observation, and we control the version of the schema upgrades and enforce the agents um, from like mutating the message formats silently. And also there's like the data hygiene, where automatic removal of private or unsafe information that you just mentioned. And we also need consistent filtering for like private secrets or privacy data. And we need safety labels that stay attached to the data so we can trace back to each piece of the data. And also evaluation also matters a lot. So we need standardized checkers that define what success and safety mean for every task. So results could be reproducible across different runs. So people can reproduce yours, mine, or other people's results easily. So in other words, the same way like internet protocols make communication safer and standardized, with ADP we aim to make intelligent action safe and standardized as well.
Excellent. Thank you so much. Let's switch gears. Let's talk about your work that you're doing regarding and linked to the MCP, right? So you have a paper that frames the beyond the browsing, right, where you basically are talking and exploring, researching the web as an action space called, right? So basically, you allow agents to call the APIs instead of clicking through pixels, right? So let's think a step forward in a world in which we are surrounded by robots, and virtual agents are in full motions, right? And they are basically interacting through structured interfaces rather than screenshots, right? So what happens exactly there when that is going to be the default case?
Although like our paper only examines the agent in a web scale, but like if we have robots that can also learn or interact through like such structured interfaces, I think it will be transformative. Because like when agents move from screenshots to APIs, they move from like guessing to reasoning as well. Screenshots are noisy and ambiguous, like they are designed for humans, and we are able to handle like very noisy stuff. For example, on the screens, they change layouts or hide context so that people need to find the context, need to search to find the context, and sometimes require constant retraining. While APIs, on the other hand, are like contracts. They tell you exactly what inputs are valid and what inputs are not valid, what outputs to expect given the inputs, and what can go wrong with the wrong inputs. Let's say for embodied or digital agents, this means more predictable, inspectable, and composable control. The agent can say like, I know how to book this, fetch that poster um, with the environment without hallucinating like click passes like in the web. It's like giving the agent a keyboard for the web, not just a camera and a mouse as before. Um, yeah.
Fascinating. And so these I'll call them, native MCPs, right? They could, in theory, become the next version, the replaceable for anything that is embodied AI, right? And that could make the way, right, into really how we use, or robots machine use website and services, even physically, right, that are operable by agents, right? What are your thoughts here?
Um, I think that's where um, the research community is heading. Like we have the research community have spent years trying to make robots to see the digital world with their own eyes, like
Yeah.
through vision. Now
Mm.
we can make the digital world speak to the robot. So, for example, let's say in an ideal world where every service exposes a standardized, also very structured authenticated APIs, ideally in the standard MCP style, agents could interact safely and efficiently with like the every service. Let's say, for example, let's imagine a household robot that can directly order, let's say, order pizza, schedule maintenance, or let's say fetch real world data without scraping a web page. So instead of reinventing um, the data the site for each website, we want to build a shared like or structured interface where the digital twin of the physical world um, is able to manipulate with. I think it's a huge step toward a world where every online action is physically executable for the agent.
Executable, therefore searchable, right? Contextual, relevant, right? And
Yeah.
then this creates truly a new definition of what once was really called the maybe the web one or the internet or one, right? So but obviously safety here becomes I mean, not just safety but stability, right? This becomes fundamentally important for anything that is linked and related to what we today see as default APIs, right? So when we think of standards, right? Where do you see the next version of APIs going in order to have this autonomous use, right, linked to stability and safety, and explainable tools in general, right?
Right. Like right now, there's no like one single standard that could
Right.
make guys the best tool for autonomous use. So to make this able to be used by like agents, we need like new norms or definition in both design and governance. For example, on the technical side, we need like tagged schemas, structured schemas with clear input-output contracts. So every agent knows like how to input, how to interact with the schema, and we need correct like safety design so that like if the agent need to retry with the website, it shouldn't cause any harm. Also, we need rate limits um, and explicit back-off guidance to the agent. We need readable error message and stable versioning so that both humans and agents are able to understand what's happening and where to return to if something goes wrong. Also, we need sandbox and simulation endpoints at the beginning because this could help with safe testing. Actually, many papers are using sandbox to ensure that no harm is actually caused.
Mm,
Um, Also, on the social side, we need ecosystems where developers can declare that this API is safe for agents, like with verifiable metadata and audit logs, such that every developer and agent could verify this. Also, I think it's the same principle as autonomous vehicles, where certification, like predictability, and human override are very important stuff to
mm,
consider.
mm.
And once that foundation exists, the entire web becomes a programmable interface for physical AI. So it's like physical API that are safe, inspectable, and standardized to collaborate between for humans to collaborate with agents.
That is very compelling. Physical APIs. That's yeah. I can see that definitely being a fundamental urgent need, right? So that the physical becomes more safer and more default, more standardized, right, for machines to interoperate with them. That is
Yes.
congratulations on your work, Kaylin. Let's switch into the third gear, into the topic of reasoning without domain knowledge, specifically, talking about the fact that yeah, multimodals still nowadays, right, fail at compositional logic, spatial interference, and analogy, meaning AI knows everything, or apparently, right, but understands actually a little, right, and we have here underlying truly evidences with visual puzzles that isolates reasoning from prior knowledge, revealing that fact, right? So why do models scale in actual language but stagnate in reasoning? What are your findings there, Kaylin? What can you share with us?
Like in our paper, we built a benchmark, like testing whether models could, like multimodal models could successfully solve visual puzzles task, where they are tested on like logical reasoning that are isolated from domain-specific knowledge. Um, where our main finding is that scaling actually amplifies the pattern recall but not structure thinking. So models are not actually performing structure thinking, they are just like recalling the patterns they learn from training. um, so for example, when models are trained, they could see like billions or even trillions of examples where they get familiar to like some special sequences like words, images, code, but they're not actually simulating the cultural structure of the world like humans. Reasoning like human reasoning requires internal computation, like we need to maintain wearable, test hypothesis, and remember partial results and revise our plans when we encounter any errors. But however, that's not today's models were built for. At least that's what we tested for from visual puzzles.
Right.
Um, so in visual puzzles, we remove all the world knowledge, so the model can't fake their understanding from what they've learned before. And we see that pure scaling doesn't actually help. It's like asking a parrot to solve algebra questions. Although the parrot might be good at vocabulary, that doesn't make the parrot better at reasoning. So we need architectures that reason symbolically inside a continuous space. We want object-centric representation, persistent memory, geometric attention, and models that can branch and backtrace, just like humans.
Fundamentally important, right? Because this is for physical AI, it's super urgent, right? So that robot go beyond just the let's say the default encyclopedic scrape data memory, right? But they need also structured imagination for that, right? So and so what does it exactly make us reflect and teach us, right? If this missing architecture for models, right, can in theory infer, adapt and recover in physical settings, right? So what does it teach us?
I think it essentially teaches us that a true world model needs to um, not only describe the world but also simulate the world. Like for physical AI, that means a system that can test consequences internally before acting out the consequences. They need causal consistency, temporal awareness, physical grounded priors, etc. So in other words, a true world model shouldn't just predict the next frame or the next action. It should ask, like, if I did this action, would it still hold together everything? Would things still work out? Like these models should blend symbolic reasoning and sensory grounding together, um, just like how humans imagine and predict in 3 dimensions before we act. So rather than bigger language models, we should aim for interactive simulators that couple several important things like perception, reasoning, and feedback. That's the architectural missing thing here.
Yeah, because otherwise the entire, let's say, job to be done, the flow, right, it breaks apart if we just predict the next action, right? If you don't understand the spatial environment, the reasoning, the semantics, right, the nuances of it, right, and as a machine you would be not able to fulfill a safe action, right, to only have a next step, and that doesn't really solve then basically the actual job, right? So how can we turn reasoning benchmark like what you're talking in visual puzzles, right, into kind of training curricula, right, for embodied agents without truly leaking shortcuts? What are your thoughts there?
Um, I think to be honest, I don't think models should just be fine-tuned on puzzles like this, like visual puzzles, because the models would just like memorize the answers or memorize the patterns. But you can turn them into procedure curriculum, like generate rule systems dynamically and represent them as structured tasks and train the agents to hypothesize, execute, and verify solutions. We can even integrate this with like what we call APIs or tools, where we can integrate with like geometric solvers, logic checkers, and causal simulators, just like what we have when we are taking math classes. So reasoning isn't text only, but also grounded in outcomes. So models or agents could like have access to these outcomes. The idea is to like reward, let's say, repair and verification rather than just like the final answers. So when an agent proposes a plan, it must check like the conditions or the constraints, like whether everything is in order, whether everything is reachable, yeah, and correct itself when it faces errors. So that's how models should be moved from language reasoning to actionable reasoning, like from talking about the world to thinking with the world. So, if to summarize this with one sentence, we need to stop training agents to be like worthy, and we need to start training them to be correct.
Yeah, and that is a very compelling challenge we have, and also um, the agentic work here to understand the contextuality so that they are contextually aware, might eventually require to have multi-agentic infrastructure rather than focusing just on one solution fits all, right? What are your thoughts there?
Yeah, I think this is very important. I mean, sometimes, like for example, when we the insights we gain from visual puzzles is that they just memorize everything and use the same patterns or similar patterns for even different reasoning tasks. Um, so for different reasoning types, like humans' brains light up when it comes to different reasoning problems. But like for models, we noticed that there's a high correlation between very different reasoning tasks. Also, examining the patterns, we found that like um, models like use the same reasoning pattern for even the very different reasoning tasks. So this implies that models might be using like memorized patterns instead of actually reasoning about the task. So um, I think models here should be able to understand the context they are provided in and act differently based on the context requirements instead of like just using the same thing for very different contexts. So yeah, this is important.
Kaylin, congratulations on your work. I love to learn with and from you. Share with our audience your perspective on how this entire world, in your view, and what I mean with the entire world is it goes without saying that robots will be one of the most fundamental species slash machine that will be surrounding us, right, in the next 10 to 15, 20 years. And it will become a default. We'll have autonomous driving, we'll have drones, and in those we have embodied AI, right? So whatever we have been discussing today will be basically making machines smarter to reasons around the world, right? And obviously we as a human being will be benefiting from those machines doing jobs that are either repetitive or unsafe for us to do, right? But how can the humanity benefit from when AI meets the physical world? What are your thoughts there in terms of the actual direct link between an augmented, a richer way of living life through physical AI and how the human being can benefit from it?
I do think like robots in the future can benefit humans through the physical world. Like for example, there are already research on how cooking agents can help people who really don't like cooking but wants to eat at home. Like how household agents could help like the blind people. Yeah. So in the physical world, um, not everything is like structured as like what we just discussed in like for example the web agent or even the generalist computer agents. Not everything is as structured, but like we could still convert existing trajectories or existing work to standardized infrastructure that allows agent to better interact with, and through like enabling the agent a better reasoning ability, like they could further utilize this infrastructure and available tools in the world to help humans. um, I do imagine that in the future humans would collaborate with agents instead of solely relying on the agents in the physical world, because the physical world is more unstructured like than the computer, uh like in the computers were like in like some fixed action spaces. So I think in the future physical world, yeah, I think it's more likely that humans will collaborate with agents instead of relying on the agents.
Yeah. So basically, we will see a world in which we, on one hand, benefit from smarter devices helping us, and on the other hand, we have an augmented and enriched a smarter world that is provided to the human senses, that is more contextual aware, and that translate in us interacting with the physical world in ways that through the analog world, right, were not possible interacting with, right? And for that, we need a series of agents that provide at the right time the right meaning to us, right? And meaning obviously based on an individualistic and a bespoke manner, right? Very, very excited. Kaylyn, again, thank you so much. Give it up for Kaylyn, and I'll say goodbye. I'll see you in the digital world, Kaylyn. Thank you so much. Talk to you soon.
Thank you.